Hi, thanks for joining us today. We're going to be working on 5-4. This is the third part. Today we're going to be talking about how we can use anti-differentiation or integration on position, velocity, and acceleration problems. The last time we did anything with position, velocity, acceleration in these videos was lesson 3-1. So if you want to go watch those videos first, please do. That would give you the maximum effect, the maximum potency of this video. So in that lesson, we talked about this. Lesson 3-1 was all about how if I know the position equation, I could take the derivative to get the velocity equation. I could take the derivative of velocity to get to acceleration. Now, if we know the acceleration equation for an object and initial conditions, I could go from the acceleration back to velocity. I could go from velocity back to position. Okay? Because, again, integration undoes differentiation. So let's put that into effect. The acceleration of a particle is given by a of t equals 4t minus 3. So, they want us to find the velocity equation if we know that v of 1 equals 6. Well, v of t would be the antiderivative or the integral of a of t dt, or the antiderivative of 4t minus 3 dt. That would just be 4t squared. I added 1 to the power. The power here is 1. And I'm going to divide by the new power. Minus the antiderivative of negative 3 is, if you said or thought 3t, you're right, not 3x, because it's with respect to t, plus c. So that means, so v of t is potentially 4t squared. Here, let's simplify it as we go. 4t squared divided by 2, 2t squared minus 3t plus c. Now we use the initial condition. V of 1 equals 6. Well, I know what v of 1 is if I replace all the t's with 1's. It'd be 2 times 1 squared minus 3 times 1 plus c. So 6 equals 2 minus 3, negative 1. 2 minus 3 is negative 1 plus c. So c equals 7. Okay? And again, combining these two, we get that the velocity equation for this particle would be 2t squared minus 3t plus 7. Combining the techniques from the previous video and 3-1. Please make sure you understand that. We're going to do it again with the position equation, but the work here depends on this work. If you need to watch that again, please do. Please do. So the position equation should be the antiderivative of the velocity equation. Since velocity is the derivative of position, position is the antiderivative of velocity. So just substituting in, squared minus 3t plus 7 dt. So s of t would be 2t cubed divided by 3 minus 3t squared. I add 1 to the power, divide by the new power. The integral of 7 is 7t plus c. I'm going to call this c2. Since I've been doing, I did a problem with c, we call this c1. Okay, it's technically a different c. I have seen FRQs problems, FRQs before, FRQ problems, free response questions where people have gotten points deducted. You technically want to use a different constant because this constant could be different than that constant. They should not be the same constants. Okay? It's a little bit of a technical detail, but it's important. Somewhat important. Now we're using this initial condition. So S sub 2 would equal 2 times 2 cubed over 3 minus 3 times 2 squared over 2 minus 7 times 2 plus 7 times 2 plus the second constant. S of 2 is 5. This is 16 over 3. This is just 6. This is 14. This is C2. Now, if you're not in a simplifying mood, it is okay to just get C2 isolated. C2 equals 5 minus 16 thirds plus 6, add 6 to both sides, minus 14 to both sides. That's just fine. You don't get any points for simplifying that. You probably waste time. It's even worse if you waste the time simplifying it and then simplify it wrong. You've hurt yourself twice. So just be careful. What I'm trying to say, it is totally fine to write S of t equals 2t cubed over 3 minus 3t squared over 2 plus 7t plus 5 minus 16 thirds plus 6 minus 14. That is a completely acceptable answer on the AP test. That is a completely acceptable answer on my tests. Would it kill you to do 6 minus 14 is negative 8? I don't know, maybe. It would be nice to simplify the non-fraction parts. If it was me taking the test, I'd probably simplify the non-fraction parts, personally. Which, FYI, would be negative 3. It's not that bad. All right. Now a more technical detour. So, if you've never taken physics before, we have some useful equations that describe motion on Earth for any object in free fall. Here we're going to derive them, so you don't have to derive them again. It is sometimes useful to have this memorized for the AP test or for my tests. So on Earth, the acceleration due to gravity is this. So that means A of t equals negative 32. Develop the equation of the velocity of the object if v naught is just the initial velocity. So that's v sub naught, or v of 0. So that's velocity at time 0. That's what that notation's for. Again, review 3-1 for maximum effect here. Okay, so v of t would be the antiderivative of a of t, which is just negative 32 dt. So v of t will just be negative 32t plus c1. I'm going to do two different ones. Preparing ahead. I know the initial velocity is v naught. Just that's the symbol we're using. It's just some constant. So v at time 0, replace all the t's with zeros, V of 0 is V naught. So V naught is just C1. So putting these two together. On Earth, the velocity of an object at any time, for if that object's just falling down, is negative 32t plus the initial velocity of an object. That's it. It's a little weird to use that symbol. It's okay. So this initial position equation is the same kind of thing. S sub 0, when you plug in 0, that's you just get S naught, or snot. Ha 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 ha. So funny. So this is negative 32t. I'm going to anti-differentiate velocity because velocity is the derivative of position. So position is the antiderivative of velocity. So S of t equals negative 32 t squared divided by 2 plus V naught times t plus some other constant. We use the initial condition. The same process as the last three problems. That would all be 0. That would all be 0. That would be C2. So S sub 0 is just C2. Combining these two now, we get S of t, the position at times t, time t. We can simplify that a bit. Negative 16 t squared plus V naught t plus S naught. So these two equations are called the kinematic equations, 3 if you include the acceleration, are the kinematic equations concerning motion. Equations of motion of objects in free fall on Earth. I highly recommend you memorize these two so you have an easier time on the AP test or on my test and don't have to go derive these equations every single time. That would waste your time. You should memorize these two equations. You'll likely start to memorize them a bit. You can memorize them while you're doing 19 through 22 on page 93. Good luck with that. You guys have a lot of fun. Goodbye for now. Have a nice day.